Hi everyone, it's Charlie. Hey, I just want to put some thought into the next build, and what I'd like to do is make another bass rig, and I just want to get some ideas from you, as well as I guess get a bit of an idea of what I'm thinking, and then I can sort of potter over that, think about that over the next couple of weeks before getting into it. My thoughts is to do a simple single conversion superhet, and I think the approach I wouldn't mind doing is, and we'll talk about some of the components, but very simply on the receive we'll have the antenna, we'll go through a pre-selector and then into a receive amplifier, and then to the mixer. The mixer, in fact we'll talk about that in a sec. The IF strip will be an IF amp, a crystal filter, and a second IF amp. I haven't drawn any lines here because I want to make that switchable, so rather than having in some configurations 4 amplifiers, 2 for receive and 2 for transmit, I'm just going to have one amplifier block which effectively gets switched between transmit and receive. Second mixer over here into an audio frequency power amplifier, in other words, an AF amp, and then the speaker. On transmit, microphone amplifier into the balanced modulator, and then, like I say, through that same strip again, and then back out through the linear power amp low pass filter. So a very simple superhet. I wouldn't mind sticking with either. I'm happy. I'll probably go with the SI5351, and that was actually going to be another question. Are people interested in building a superhet, so a single sideband radio, or would they prefer doing a double sideband suppressed carrier transceiver? Somewhat simpler. We won't require that. We'll just have the one mixer, and we'll come straight down to DC and then back up again. If we do go for a double sideband suppressed carrier, then I may look to use an AD9850 digital synthesis chip or board. This one here only has one output, which makes it suitable for that. I could use 2 in this configuration if we wanted to, one for the VFO and one for the BFO. If we do stick with going with a superhet, then I'll probably just go back to using what I have been using for quite some time now, which is the SI5351 board from Adafruit. It's a great little board. It's easy to use. There's only 4 pins, so VCC and ground, and then the SDA and SCL, which makes it nice and simple. It's got 3 clock outputs. We only use, well, I only bother to use clock 0 and clock 2. So we can basically look at using that. And what I'm thinking for, in terms of components, in fact I'll leave it there for now. On the receive side, for the amplifiers, in fact for all the amplifiers, and we'll talk a little bit more about the power amplifier here, I wouldn't mind using just standard components, so sort of simple components you can get off the shelf. And my thoughts were using the 3906, or 3904, sorry, the NPN. And you can buy these cheapest chips, and I'm not quite sure where I got these strips from. I think it might have been off Amazon quite some time ago, and it costs next to nothing for these things. So I was thinking about doing making the amplifiers out of these. And what I also want to do for the whole radio, for this whole build here, is look more in depth at the maths behind it. So we'll look at the biasing for the various amplifiers, and I'll probably just go for a standard voltage divider biasing. So how we set the quiescent current, how we set the voltage divider biasing to get that quiescent current, and then set the input impedance and the like. So I wouldn't mind concentrating more for this whole build on cracking open my good old calculator, and we can start punching in and doing some numbers on that. And then once we've got the circuit designed on paper, then it would be my intent to transfer that to LTSpice, and we'll simulate it, and then we can tweak it to suit the band. I will make this for 80 meters, but there's no reason why anybody who's building this couldn't use exactly the same approach. And as long as the pre-selectors and the bandpass filters that is designed for the frequency, it should be fine. And I've just noticed here I am going to have another bandpass filter in the strip here. I find that quite useful just to clean out the signal prior going to linear power amp, so there should be one sitting there as well. So that's my intent, like I say, so to do the maths and then to simulate on LTSpice, and we'll make videos on that before actually committing it to the circuit board and melting some solder. So that would be my intent, and like I say, I wouldn't mind using sort of stock standard components off the shelf. So for this build, not that the J310 was hard to get, but let's do something different and we'll use just a stock standard bipolar transistor. For these mixers, what I wanted to do this time, let's not use, well, it's my suggestion that we don't use the NE612 or say the SBL1. Let's go old school and let's hand build or home brew some double balance mixers. So we'll need to crack open some FT37-43s and then we'll use the old IN914s or the 4148s, and we will make up a little circuit there to match 4 of them, and then we'll get into the game of building a balanced mixer. And so that's what I'm suggesting we do for here, just to do something different. We'll go back and we'll make it up from scratch, and then we can build a video around the winding of those as well as the matching of the four diodes. So that's what I'm suggesting we do for these two mixers here. For the crystal filter, I don't unfortunately have a ready store here of crystals, so I'm just going to reach into the old junk box and have a go at using this one again. I tried using this one in the last build, and for whatever reason I couldn't get it to work, so I wouldn't mind just giving that another go again. If I recall, it's sitting on, if I get my glasses, it's got a center frequency of 9.22 megahertz. So I think we'll look at using that for the crystal filter, and we'll see how we get on with that. Driving the SI5351 will be an Arduino again. Sort of opening up the junk box, got a couple of those sort of lying around. We could use the Mega here if we wanted to. Or here's an old I can't pronounce that, Doom level of, but might look at using that once it's been overused for some other project. So we could look at using, say, those as opposed to the small Arduino Pro Mini, which I have been using in the past. For the screen, I have been using these little OLEDs. Again, very easy to use, VCC and ground and SDA and SCL. I find these are not all the same when they come. The configuration of the pins are subtly different, but more importantly, some are RF quiet and some aren't. The last little tramping radio build, if we turn the volume right down to 0, I found I could just hear some noise coming through from that. When you turn the volume up though, it was quickly drowned out, but it was just a tad annoying. So what I might look to do is just have a play around with this 2-line 16 segment LCD. This one has on the back the parallel to I2C interface, so again we'll get the standard pins out, the VCC and ground and SDA and SCL. So I might look to use that, and we'll just have a bit of a play and see how quiet that is from an RF point of view. So that's what I'm sort of suggesting we do there. Again, now the junk box, an old meter here. This one's actually quite an interesting one, which I think I'll look to use. Hopefully it's the camera will pick it up. On the red scale there, we've got 0 to 10. So what I think we might do is we'll do a pickup up here somewhere, and we'll measure the output power coming out, because this will be a QRP rig again, so I'm not going to, well, I doubt I'm going to exceed 10 watts. So it'll be quite interesting just to have sort of 0 to 10 watts as an output power meter. Then on receive, we'll look to detect somewhere a level as a function of the received signal, which we can then calibrate one way or another, and display it on that second black scale, which is our standard S-meter scale. So be my contention or intention, as I say, to use that. On the microphone side over here, I think again in the junk box got this old Tate radio microphone, so I think we'll look to use that. And because it's got the PTT switch in it, what I'll do this time, rather than having a simple double pole double throw switch, which I have been using because it's just quick and simple, I'll utilise a relay for that, and then we can use the PTT to pick up and trigger that particular relay. So that's what I'm thinking there. Yeah, just looking at my notes here, I think we talked about using LTSpice, which I'm keen to do, as well as the coding. So I think I haven't drawn on this picture down here, but the Arduino code here, we'll do a video looking at the code that drives this. Nothing special there, but for people who want to give coding a go, we will do a video on looking at the code. What else we got here? So for the power amp, so the linear power amp here, again, I'm pretty easy from a simplicity point of view. I'm sort of thinking about using some 2N 3053s. So I've got a few of those lying around the junk box. So I'm sort of thinking we could have a either a 2N 2222, or again, if we stick to our sort of 2N 3904, have a 3904 pre-driver into two stages of 2N 3053s, and then into some BD 139s. Maybe not so much a JBot style, but you know, I'm sort of open to either go for a single-ended linear power amplifier, or maybe a push-pull. So yeah, I'm sort of open to that one, but again, sort of in the idea of using sort of common components, that's what I was thinking for the linear power amplifier, and that's as opposed to, say, using the IRF 510. So sort of stick with a more of a traditional voltage divider biasing linear power amplifier. I was very kindly given these a short while ago, the Motorola MRF 644s. These are a UHF device, good for 25 watts, but you know, there'd be a heck of a lot more power than that if we run them down at, say, 3.5 megs at some point in time. And I don't know if it's going to be part of this project, but I wouldn't mind doing a making these into a nice push-pull amplifier to, you know, hopefully potentially get up to that sort of 20 watt range. So it won't be part of this build, but at some point in time I'm quite keen, in fact I'm very keen to work out how I'm going to design a radio, say again, a power amplifier around those. So that's still a will be a work in progress in due course. Yeah, so we talked about, yeah, so back to that display, the other option I was thinking about, I will run with this for a start, but you do see the cheap Nokia screens, you know, they're down to a couple of dollars now. It's an LCD screen. I don't know if I want to use one of those. For these radios here, all I'm really displaying is the frequency. So, you know, there's no point having a massive screen with lots of real estate if you're only displaying a small amount of information. So I think for now I might stick with this. If I do find that this is RF noisy, then I'll get sent in a one of those little, in fact I'll get it pre-sent here, one of those little Nokia, I think it's a 5110 if I recall, screen, and we'll give that a go as well. Anyway, that's been 14 minutes, so I might knock it on the head there. Please, whatever ideas you got, feed them in. But that's my current thinking, and like I say, very keen to do more of the maths, to do more of the simulations with LTSpice, and trying to sort of do some learnings that way, do some learnings around some old school double balance mixer creation, and we'll look at also the bandpass filters, making those up using the coefficients out of the a radio amateur design book. So I'll leave it on there. Apologies for such a long video, but like I say, this is just sort of getting the old juices flowing and thinking about what we might want to do for the next series, and what level of detail we want to put into that. So I'll say 73s, and looking forward to your feedback. Cheers all.